Welcome to another Syvecs demonstration. Today we're going to go over the traction control strategy on the Syvecs range. We're going to work out and show you how the strategy is implemented and how you can go about setting it up. Okay, so actually we're in SCAL at the moment, as you can see. Loaded in front of us we have the traction control area. Okay, the first thing we need to do before implementing anything in the traction control area is assign certain values in the I/O configuration. If we go down to the I/O configuration and pin assignments, in here you have a list of all the inputs and outputs which are available on the ECU. When you actually highlight an option by pressing enter or double clicking on it, you can see which values are actually spare, illustrated in white. Okay. What we need to do to make the traction control work is we need to assign vehicle speed sensors on each wheel. Okay. So you can see in this car here, which we've got a Supra stock map, the front wheels are assigned to the AN07 and AN08, and the rear wheel is assigned to AN03 and AN04. Now you can work out which inputs these are by looking at the S6GP pinout assignment and wiring guide, which is found on the Syvecs forum. Okay. Please note that with the traction control strategy on the S6 specifically, you need to use Syvecs signal adapters for the front wheels. The reason for this is we only have 4 bipolar spare inputs, and bipolars and inputs that are able to work above the reference ground and below it and see a waveform. We have unipolar inputs, but they're no good really for the ABS. So in order to make the front wheels work, we use the 2 spare bipolar inputs for the rear, and the other 2 are used for the crank and cam. And then what we do is we use 2 unipolar inputs, and using signal converters from Syvecs, we enable the actual system to still pick up those wheel speed sensors and work fine. Okay, so once you've assigned these 4 items into the vehicle speed and you understand which wheel is which input, you can actually test this by creating a gauge and viewing it. We're actually not live on the ECU at the moment, so you won't be able to see it in real time, but I can just show you how to quickly do that. What you need to do is go to gauge up here, or press the letter G on the keyboard. Once you've done that, you can actually then go to add or press A again. Here you have a list of all the gauge items that are available to view. What we specifically want to look at is we want to look at the AN07, AN08, AN04 and AN03 to see if they're actually getting a signal on those inputs. Okay, so the first thing to do is go onto AN03 and then view it as a trace, and you can view that up to 100 times a second, so I'll go 100 Hz. Now when you start moving the wheel, hopefully this box down here will then start to register a difference in voltage as the magnetic sensor is starting to pick up a difference. Once you've got that, you then need to program those changes into the ECU by going device and then program. Again, we're not live, so it's not actually going to do that here, but just press device and then program, or keyboard shortcut D and then P. Once you've done that, the actual AN inputs would be assigned to the actual specific wheels, and then we need to go and set them up. Okay, so what we do then is go to the sensors. When you go to sensors, you then go down to vehicle speed. In here, we need to now first enter the dryer tyre circumference for the wheels that you're going to be using. Okay, so you can work this out by using a few tools on the internet, or just doing some basic maths. Okay, but this is the actual circumference of the tyre. As you can see on the Supra, that particularly on the base map, we have all the 4 same size wheels. Okay, but you need to populate this correctly in order to make sure the vehicle speed on each wheel is actually 100%. Okay, once you've done that, if you're ever going to be using on a track car different types of tyres, you can actually populate these with the different circumferences for the tyres that we're using. Okay, next we need to go down to the tooth timeouts. What this means is this: if no actual teeth are seen on the wheel input when the actual car is stationary, the actual ECU considers the wheel to be stationary. Okay, so that's what you need to put in there as a timeout. At standard, we've got half a second. The number of teeth on your onto each wheel on the ABS unit. Here you pop in the number of teeth that's actually on the actual trigger wheel in the ABS unit. On the Supra is 48. And then what you can define here is the number of teeth per reading, which every time one revolution of the trigger wheel is taken, this is how many times it looks to see how many teeth it picks up on. You can see on here at the moment we've got 4, so on every revolution it looks for it takes 4 teeth per reading. What you've got then is the low threshold voltages and the high threshold voltages. If we go into here at the moment, as the rear right and rear left are using the bipolar input, we've generally got a low threshold voltage of 0.25, and where the front wheels are using the Syvecs signal converters, this actually converts the wheel speed to a square waveform. So we have the low thresholds quite a bit higher because the waveform will go up to above 3.75 volts and then drop back down to 0. Okay, so whereas the bipolar input, obviously, as the speed of the wheel increases, so will the voltage. Okay. Once you've put them in there, again, for the high threshold, these are generally, if you're using the Syvecs signal converters or you're using bipolar inputs, these are generally right stuff to put into here to make it actual bipolar signal, see the wheel speeds and work. Input configuration, this is where obviously you can put in here the type of input that's been put on. Obviously we're using the 5 volt input for the wheel speeds sensor at the back. On the base mat, and the fronts are used as thermistors. The reason we got them as thermistors is because on the using the Syvecs signal converters, a pull-up is required in order to actually register an actual signal. Okay, if you're actually starting to use other sensors on the actual Syvecs strategy for traction control, like lateral G and that, you can actually put in here the minimum lateral G for wheel speed conditioning. And then you've got a few other parameters for max unloaded wheel speed variation, and here the main bits you want to define is obviously where the vehicle speed is being selected from. So on this car, on this base map, we've got it set as front left. Obviously if both the wheel speeds are actually defined, then we want to put that as, on this particular car, say if we actually had both of them defined, on average front, or an average condition front if you wanted some filters put on it. But generally average front seems to work well. Then you go down to driven speed select, and on this obviously both the rear wheels are used again, so on this one we want to put average rear. Okay. Lap distance at pit switch release, again you can define a few other options. If you're using the kind of track and you've got the pit switch enabled, you can set points in which certain traction control strategy is used differently at different points of a lap distance, different slip targets, etc. So that's mainly used for more the advanced users, and it's best to speak to Syvecs direct about that. Okay, so once we defined all the vehicle's speed inputs, etc., what you want to then do is then go up to traction control. In here, okay, the first thing you need to do is actually put overall enable and turn it on. Now the Syvecs traction control system doesn't actually need a lateral G sensor or a steering angle based sensor to actually work still. You need to define one of them to actually make the system work. Okay, sorry, when I say define, I mean in the actual overall enable, it doesn't actually need a lateral G sensor or a steering angle based sensor defined in the I/O configuration. But we do recommend, obviously it's better to use a lateral G sensor with the traction control system to actually have the best strategy there is possible. So once that's available, you can go in here and select lateral G based. The minimum vehicle speed is the actual speed in which the strategy works above. Okay, the reason we have that at the moment at 17 miles an hour is because of the diff on the Supra at low speeds. It is fairly susceptible for picking up low, obviously on an inside wheel, a much different variation in speed to the other, and it can actually cause problems on the traction control system on like a tight diff, etc. So we actually set that about 17 miles an hour. Okay. But you can change that as you wish. If you've got an open diff, etc., and you're happy to have, so when you're driving around town, you can actually then say, I want to switch traction control off, or if you want it from a lower speed, then you can define that here. Okay. On a gear cut, if you're using a gear cut strategy, you can have a disabled time after a gear cut. So where the actual ramp in is coming back in through the actual gear cut strategy, you can actually define it so the traction control is off for a set amount of time. The vehicle speed breakpoints allow you to actually define the actual breakpoints in which the maps are used for. So in the vehicle speed breakpoints here, you can actually define the actual points in which you want different slip targets to be available. So what we're going to do on this particular car, we're using the lateral G based traction control strategy. So we're going to go into the lateral G based target area. So as you can see here, based on the vehicle speed breakpoints which were set and the lateral G breakpoints that were set, it allows you to define a certain amount of slip based on vehicle speed. So you can see here on this particular car we actually haven't got a lateral G sensor actually put into the car. If you did have a lateral G sensor based in it, as you come down and lateral G is detected, normally you'd want it to actually pull out lower the actual slip target. So in the event of the car going sideways, the slip target is lowered, the actual wheel spin parameter goes over this value and torque reduction is applied. Okay, so and you've got 4 maps on here, okay, and once you've set them up and the different slip targets you want, obviously it's best to have them different variations in that. So when you're on the calibration switch or you've got a traction control switch, you can actually change the traction control that you like and the amount of slip. Okay, minimum spin target. Okay, so this is where we get into how the traction control system works. When you've got the 4 wheel speeds defined in the I/O configuration, and all the vehicle speeds are actually working, as well as defining the vehicle speed and driven speed, a parameter will become available which is called wheel spin. We can actually add that here. Go wheel spin. Once you've got the wheel spin gauge in front of you, you can actually see when there's a difference between the front and rear wheels, this value will either go plus or minus. Okay, when the actual wheel spin value goes above the minimum spin target and also above the spin target that you've actually set in the map, torque reduction is applied based on how far you are actually over that spin target. Okay, so the easiest thing to do is set up your logging to view, say, TC torque, wheel spin, and all the 4 individual wheel speed sensors, as well as vehicle speed and driven speed, and the TC spin target, to see actually what is actually going on during the logging and to get the actual system set up 100%. What you've got is you've actually then got a base gain value which allows you to adjust all the base gains that the actual strategy applies based on how far you go over the traction control to how much the traction control spin error is. So the more you actually raise this, obviously the more aggressive the strategy becomes, and the lower you reduce it, obviously it becomes a bit less aggressive. Generally speaking, we tend to say to leave that at 5, but if you wanted to have it so on a specific map that you weren't so aggressive, you can actually change down the calibration switch, which we'll show again in a minute. So the torque reduction clamp defines a maximum clamp of torque reduction that can be applied during a wheel spin event. Generally speaking, when the engine is making less power or torque at lower RPM, you don't actually want so much of a torque reduction there, because obviously it can become too much. This is just a base map at the moment, but you can define this to how you wish. Generally speaking, we don't suggest to really go above more than, say, 60%. After that, then obviously the torque reduction clamp becomes so severe that it actually causes the car and the traction control not to become too nice when it is active. Now this torque reduction clamp links into the TC torque parameter, and the TC torque parameter here, you can define how much fuel cut severity you have based on the TC torque which is actually applied. So again, going back to the logging, what you want to look at is the wheel spin, your TC spin target, and how far the wheel spin value has gone over the target. Based on that, how far it's gone over, a TC torque will be applied and worked out from the actual strategy and calculation. What you can do then is you can actually see how much the TC torque has been applied, and if you find that it's not actually enough torque reduction, you can actually change your fuel cut severity and ignition retard table to actually suit reducing all the torque 100%. Generally speaking, these values that are punched in here at the moment tend to work very well, but obviously this is up to the end tuner to play with and actually get the actual traction control working perfectly. So once you've set this all up, recommend obviously viewing in sconfig, and so you can actually define the actual parameters you wish to log. The ones over here are the ones that generally tend to be used with the traction control strategy. So once you've got those set, obviously look at the logging and actually get the system set up well. Now going back to the calibration switch in here, there is actually an area which is defined as traction control and allows you to select different target maps based on where the calibration switch is, or your say traction control switch. So you can actually change between different slip target maps live, and you can also change like a multiplier if you wanted to on each like target map, as well as gain tuning. Now the best way to turn off the traction control if you wanted to on a calibration switch is to set the gain tuning at 0 on that particular switch. Okay, so if you've got a gain of 0, no torque reduction will be applied, so the traction control is actually turned off. Okay, and you've also got torque reduction linear decay rate, so that's how fast the torque reduction is reapplied at a stated rate, and you can actually change that live on the actual cal switch again, and the re-excursion of the decay of the traction control as well. Okay, now if you wanted to have your own traction control calibration switch, you can actually define that here in the I/O configuration under traction control switch, and then that traction control switch will only edit the stuff that's in here, and you will actually be defined a TC switch here, and if you double click on it, it shows the parameter down here and actually shows you live what that switch position is. Okay, to go through how the calibration switches are set up, etc., we recommend you looking at the basic manual to do a bit more about that. But hopefully this guide will help you to get your traction control working smoothly. Any problems, then it's best to contact the Syvecs help team via either sales@Syvecs or go direct to Ryan@syvecs.co.uk. I hope this has been useful, and look out for the next one. Thanks.